A diastereomer is a type of stereoisomer that it's not a mirror image from the initial molecule. Remember that enantiomers are complete mirror images, and that means that the configuration in all the chiral centers is the opposite. In the case of diastereomers, the structures have some of the chiral centers flipped, but not all of them. To find the number of possible diastereomers, we can simply look at the number of stereocenters and use the formula 2 to the n. N is the number of chiral centers. So, if a molecule has 2 stereocenters, it could have 4 diastereomers. And if a molecule has 3 chiral centers, it will have 8 stereoisomers. For example, let's look at the molecule 2,3-dibromobutane. Because the molecule has 2 stereogenic centers, the maximum number of stereoisomers that it can have is 4. Now, let's look at another molecule, 2,3-dibromopentane. Because it has 2 stereocenters, it should have 4 stereoisomers. Let's identify them. First, pick one compound and draw it using wedges and dashes. It doesn't matter where you start. In this case, you can start with A. Then, draw the mirror image, in this case, B. You will see that they are not superimposable, and therefore they are enantiomers. Then, take molecule A and switch only the groups in one of the carbons, like in the case of C. Then draw its mirror image, D. C and D are non-superimposable mirror images, and therefore they are enantiomers. Let's look at the relationships among the 4 structures that we drew. Compounds A and B are mirror images of each other, and therefore they are enantiomers. The same goes for C and D. A and C are diastereomers, as well as A and D. It means that not all the stereocenters have opposite configurations. B and C are diastereomers, and B and D as well. Pause the video here and make sure that you follow this reasoning. Each stereocenter must have its own assigned configuration. Look at this example. We will indicate the carbon number and its configuration at the beginning of the name. If the compounds are identical, their R and S assignations will match. If they are enantiomers, the assignations will be completely opposite, like RR and SS and RS and SR. If the molecules are diastereomers, not all the centers will be opposite, like RR and RS.